So just so you guys know what's going on here. I've set up my wireless router, and I connected my switch to it, and then I wanted to connect the light to the switch, but in order to do that, the IP addresses have to be configured properly. So I looked at the IP address on the fixture. It's a 2-dot address. In other words, the IP address starts with the number 2. So in order for us to work with that light on the network, we would have to set up our network to start with the 2-dot address. And so I went and changed the configuration on the router. And the way you do that is first you have to connect to the router with your laptop, and then you open up a browser page, navigate to your browser page, thank you, and you type in the IP address of the router, and then you have all the configuration options. So I was trying to change the IP address. I was trying to change the DCHP server to hand out 2-dot addresses, but for some reason I can't get that to work properly. I've never actually done that before with this particular setup. So I'm going to reset the router, which means that now we're probably going to end up with the 192.168 address. Okay, so as soon as it reboots, then I'm going to log back on. Let's see if I can do this. And again, the way you would configure it is now that I'm connected to it, I need to connect with my browser. And normally you can type in the IP address of the router. If you don't know the IP address, sometimes different manufacturers have different names you can type in. So for example, that TP link, you type in tplink.wifi.net, and that'll open up the browser page. It's password protected though. So why don't you guys see if you can get on the network. Now the name of the network has changed back to its default. So instead of APT 2018, now the name of the network is TP-Link, TP-Link, here I'll write it up here. TP-Link _ F38A. Okay, and meanwhile, I'm going to continue to try to navigate to the configuration page and see if we can have any luck with this. This should be the same password now. So if you can log on, let me know. Now remember, we still have no internet access. We're building a private network. Okay? Is anybody on it? Okay, good. Oh, okay. That's weird. Let me close mine out and try again. So here's what's happening. So once we get the router set up and you connect to the router, then the router does a handshake with your computer. The same thing happens whether it's a console, whether it's a lighting fixture, or whatever it is. It'll say, it's going to do a handshake, and it's going to say, hello, who are you? And your machine is going to say, my name is Jeff's MBP, or Red's MBP, or whatever. And then it'll say, nice to meet you. Can you tell me your MAC address? Now, a MAC address, the MAC address stands for Media Access Code Address. And that's basically an electronic serial number. When the manufacturer made your machine, they burned into permanent memory an electronic serial number called a MAC address, and that can never change. It's as if they have engraved it into metal into your machine, and you can't erase it. Can't change it. Yes, Raphael?
What's it stand for?
Media Access Code address. And so the router will then record your MAC address, and then because the router is running DHCP, if your machine is also running DHCP, your router will say, can I give you an IP address? And your machine says, yes, I want an IP address via DHCP. So it will then assign your machine an IP address. And it records that results into what's called a routing table. And then the next machine that logs on, it does the same thing. Of course, this happens very quickly. And so now we've got a list of all the devices on the network with the name of the client, your URL clients to the network, the MAC address of your device, the assigned IP address of the device. Now notice, all of the IP addresses start with 192.168.0. And then the last segment of the IP address is different. That has to be different in order for the network to work. It's no different than your street address. If your mail carrier had to deliver mail to 2 different houses with the same address, then the mail would be mixed up. So to prevent that, every house has to have a unique address. So that's like the street address. And this is a software address that can change. Your MAC address can never change. Your IP address can change. So now, what I wanted to do was to do some things with the light, but the light only gives you 2 options. There's a 2-dot address and there's a 10-dot address. And because we are using a 192.168 address, as it stands right now, we can't communicate with that light. Maybe later on, maybe at lunchtime, I will reconfigure the router, and if I can do it properly, then we can connect the light and we can do some stuff with the light, okay? But now here's the thing. Whether you're setting up a network for computers or for consoles and lights or for media servers or for video switcher or audio system, whatever it is, when you build an Ethernet network and you connect to the network, then you probably have a good idea whether or not you are actually connected to the network. But you can't be 100% sure. So how do you know? Well, here's how you know. There are things you can do, there are tools you can use to test out the network. Say, for example, I wanted to test my connection and the console's connection. If the console is connected to the network, and I wonder if we can actually, is there I'm not sure how M-Series works. Who's up on M-Series? Okay. So is there a separate fixture network and a separate console network? Yes? Okay. Can we run a cable from there to the switch? Do you have one that's that long? Okay. And then also, Sean, if you're able to turn off DHCP on the console, that would be good. So before you plug it in, turn off DHCP. We're going to connect the console to the switch and see if we can get it on the same network. And if it works properly, then the router is going to do a handshake with the console, and it's going to get its MAC address, because that's a computer. That's a computer. This is a computer. It has an Ethernet port on it back here. It's a computer that happens to have a light engine built into it. So that means that this has an IP address, that has an IP address, and if we configure it properly, we should be able to look at it on the network and communicate with it on the network, okay? And I'm going to show you how, all right? So if you have a Windows machine, how many people here have Windows? How many people have Mac? Okay. If you have a Windows machine, I want you to hold down the Windows key and press R for run, and that will open up a little window. And in that window, I want you to type CMD and hit enter. CMD for command and hit enter. And that will open up another window with the DOS prompt that looks like a greater than sign or less than sign. And if you're on a Mac, I want you in the upper right-hand corner, there's the spotlight search. I want you to
It's got a longer one.
So in the upper right-hand corner, Spotlight Search, I want you to click on the magnifying glass and type in Terminal App. And as soon as you start typing TERM, it should automatically fill it in and say, oh, I need...
Just pull the barrel off.
Okay.
You can just unscrew it.
Yeah.
Pull the barrel off.
As soon as you start typing Terminal App, or TERM, it should say Terminal App, and you can just hit Enter. And that should open a window with the DOS prompt in it. Okay? Oh, and by the way, Leo, if you already have a Mac, you don't need the app. Okay, okay. If you want to, yeah.
Updates.
Oh, understand.
I want the iPad.
You want, okay.
We're good, Zach.
Okay.
You good?
All right, so I'm going to plug this into the switch. Is DHCP turned off over there, Sean?
Yes.
Okay. There we go. Okay. Now, what you've just, the app you just opened is a whole toolbox. There are a lot of commands that you can use for various purposes. And if you really get into it and learn the stuff, there's a world of things that you can do. Okay? If you want an idea, at the DOS prompt right there, type in help and hit enter, and it'll give you a list of commands. And you'll see it's a very long list of commands. And now, it's a little bit different on Windows and Mac. Some of these commands that I call out will work with Windows and not Mac, and vice versa. And I'm going to try to remember, try to remember which is which, but I don't always remember. Now, so now I want you to up at the top, because for me, when there's a lot of information on the screen, it's confusing. So up at the top, there's a way to clear the screen. See if you can clear your screen off. Can you clear the screen? Yes? No? If you cleared the screen, raise your hand. Okay. So there are commands across the top. And I think it's on the left hand. What's it under where you clear the screen? What's the...
On Mac, it's shell new window.
A shell new... Okay, well, that's not clearing the screen. That's opening another window.
Yeah.
So there's one that says clear screen. Does anybody see that? Okay. What's that? What's it under? What's the heading is it under?
CLS is the command.
But across the top, it says File, and then Edit, and then what's that command? Or you just type in CLS?
Yeah.
Oh, okay. Then see, you learn something new all the time, right? So type in CLS. Does that clear the screen? Is that both? Does it work on Windows and on Mac, or just Windows?
Mac is Command Shift L.
Command Shift L.
That's the
For-
shortcut, or you can go into Edit.
Okay.
And it's there.
Okay. Command Shift L. Okay. Is everybody starting with the blank slate now? Okay. So here's. If you're on iPad, if you're on tablet or smartphone, then open your toolbox. If you downloaded iNet Tools, just open that. If you're on Thing, open that. And a lot of these are not going to apply on the tablet, but here's what will apply. So, regardless of which platform you're on, I want you to type in this command: PING. Ping, P-I-N-G, space, and then pick an IP address up here. And I'll make this bigger. So maybe you can see it better. So just pick any IP address up here and then hit enter. And tell me what happens, huh?
Do we choose ours or a different one?
No, a different one, not your own, a different one. Choose any IP address except your own and type PING space, type in the IP address and hit enter. If you're on a tablet or phone, just hit the ping tool and type in the IP address and start the ping. Okay? So they all start with the 192.168.0, and it's 100 through 119. Now what happens when you do that?
Request timeouts.
Okay, if you're getting a request timeout, then either you are not connected to the network, or you typed an error, or you picked an IP address that is no longer on the network. Yeah, Leo? So if you're successful, what do you see?
Reply from.
So, reply from?
Yeah.
And what else?
Gives you what is it? Packet sent, received.
It received packets, okay. What else does it say?
Approximate round trips, times.
The round trip time. So if you are on the network, if the IP address you pinged is on the network, it will tell you the amount of time it took for the round trip message. So it's sending out a message, it's going, hey, are you on the network? And it replies back and says yes. How long did that take? 64 milliseconds or something like that, okay? Now, if you're on a Mac, it's going to continue to ping it over and over and over until you press Control-C and it'll stop it. If you're on a Windows, it'll ping it 3 times and stop. Now notice that every round trip is a different length of time. Why? Because the more cars there are on the road, the more congestion, the slower the traffic is. So if you happen to ping it at a time in between everybody else's pings, it's a fast round trip. If you happen to ping it at the exact moment that everybody else did, it's going to take much longer. So the network has a certain amount of bandwidth. The roads are only so wide. It can only accommodate so many cars. If there are too many cars on the road, it slows everything down. The same thing with the network. So when we build a network, one of the things we're trying to do is we're trying to minimize the number of cars on the road. We want more buses and fewer cars. We want more multicast traffic that have busloads full of passengers rather than individual cars with one driver. Right? So that should tell you a little bit of something about the network. Now, here's something else you can try. So was anybody unsuccessful? Was anybody unable to get good data back? Did you do it, Red?
Yeah.
Okay. What was the issue?
Zach's 107 probably had gone to sleep.
Okay.
So
All right.
I pinged my list until I waited.
And I forgot to tell you, this almost always trips me up. There are all kinds of potholes in the road. One of the potholes, if you're running Windows, then you should probably turn off your firewall temporarily. To turn off your firewall, go into Settings, into Network Security, and go into Windows Defender, and turn off your firewall. But don't forget to turn it back on, because if you get home and your firewall is off and you go out on the internet, you're going to regret it. Somebody's going to hack into your computer and reward you with the virus. Don't forget to turn your firewall back on. That firewall is important to protect you against the bad guys. Now, most Macs are not running a firewall, or if they are, it doesn't seem to affect our little exercises. So, did you turn off your firewall? Everybody turn it off? Yes? Okay. Now, suppose you don't know what the IP addresses of all the devices on the network are, and you want to know. How can you find out? Well, there's a couple of different ways. One is, try this. What we're going to do, so what you just did a minute ago is that you used a unicast to ping one device. You can also broadcast a ping. The broadcast address, when these IP addresses, there are two special IP addresses. One is for the router, and that's probably, it depends on the manufacturer of the router. It's either 192.168.0.0 or it's 192.168.0.1. If you wanted to find out, you could ping one of those two addresses and you will get a response if you find it. On the other hand, there's another IP address that's reserved for broadcast. If you wanted to ping the entire network, the broadcast address is 192.168.0.255. If your firewall is off and you ping the broadcast address, every single device on the network is going to acknowledge that ping, and it will tell you the IP address for every responding device. That is on Mac. On Windows, you'll get the first three. Or there's a switch you can use. You know, a lot of these commands have what they call a switch. It's a slash, and then you append something to the command. And I think in Windows, you might try ping space /all. See if that works. Ping space /all, and I could have that wrong. That's a new one to me, and I could be forgetting the format of it. That doesn't work?
IP address must be specified.
Okay. How about, well, type help space ping. Or is it ping space help? One or the other. And look for /all. I think I just have the format wrong somehow. Yes?
So when we do .0.255, is that broadcast or multicast?
That is a broadcast. So if you ping 192.168.0.255, every device on the network should respond because you're broadcasting a ping across the network. Did you get a response?
Yeah, it's not in order, but
It's not in order. Okay. No, it's going to be they're going to respond at different times. So it'll be the quickest, or maybe not. Maybe not. Yes?
When you're pinging, what are you actually doing?
So when you're pinging, what you're doing is you're sending a message to another machine, and it's kind of like knocking on the door and seeing if you get an answer back. If you knock on the door and nobody answers, then you get a timeout request, because that means it's going to wait a certain amount of time for them to answer the door. And if nobody answers, then you're going to get a message back saying, hey, nobody answered. Okay? The purpose is to find out if your machine is on the network, if the network is working, and if the other machine is on the network and it's working. Okay? I'll give you an example. The very first time I ever tried to trigger a media server from a live console, we were running a D3 on a standalone desktop computer, and I wanted the console to trigger the queues on the media server. So we connected the cables between the media server and the console, but we could not get them to talk to each other. It wouldn't work. So I went into the terminal app and I pinged the console. And it took a while to figure out that I had the configuration on the console wrong. Once I configured it properly, then I could ping it, and now I knew I had it configured properly. Okay, so it's a tool to help you troubleshoot networks. Does that make sense? Did anybody find the Windows command to broadcast a ping? No? Okay. Well, I'll have to look that up. But anyway, so you can still use the broadcast address. It's just that in Windows, I think you only get the first three back, right? Is that right?
If you do ping /?, it should pull your command.
If you type ping space /
Yes.
then what'll happen?
You get all the ping.
Oh, you do? Okay, so Debbie is saying if you're on Windows, if you type ping space / then every device will respond. So it sounds like a wild card. So that would be another way of.
So it'll pull up all the ping commands.
I'm sorry. It'll pull up all the ping commands. Do you see one that says /all? Space /t, and then another space, Debbie? Space after /t?
Ping space / space TIPF.
Okay, so it'd be ping space /t, like in Tom, another space, 192.168.0.255, and that will ping everybody on the network. So that switch is telling it to continue to ping over and over and over again until you press, is it Control C or how do you stop it?
Control C is oh, I don't know.
Yeah, on a Windows.
Yeah, I don't Command X.
Oh, okay. Command X to stop it. Okay? Is there, yes?
Yeah, when you do 55, it only shows you 55.
Yeah, so the tools on those will be different. So I'm sorry, with a tablet and a smartphone, I'm not as familiar with those tools, so you'll have to play with it and see what you can do with it, okay? All right. Now, does anybody have any questions so far? Is everybody following along okay? Everybody understand what we're doing? All right. Now, there are some other tools you can use. For example, try this. If you're on Windows, type in ipconfig and hit Enter. And that's going to give you a list of ports on your computer. If you're on Mac, you want to type in ifconfig and hit Enter. And on a Mac, it's a little bit more cryptic, but it'll give you a list of ports that are named E0 and E1 and A0, things like that. And there'll be an IP address associated with most of them. So those are your interfaces to the network, some of which are being used and some are not. For example, your Wi-Fi you're using right now, because you're all logged onto the network. So your Wi-Fi is going to, on a Mac, your Wi-Fi is labeled E0, I believe. Hey, Jean, how you doing, man? E0 is your Wi-Fi, and E1 is your Ethernet. And then on Windows, it'll just spell it out. It'll say your wireless and all that kind of stuff. So that's valuable to know. I'll tell you why, because there are a lot of ports on your computer, a lot of interfaces on your computer. And there are two instances where you need to know where the data is either coming from or it's going to. That little video I showed you yesterday of the pixel mapping, so I had a laptop running Windows, running the pixel mapping software, and I had a USB to Ethernet adapter plugged into the laptop. Then I had an Ethernet cable plugged into that going to the switch. And then I had a pixel driver plugged into the switch and the LED tape connected to the pixel driver. When I got everything configured properly, and I knew it was configured properly because I could ping from the laptop to the pixel driver, so I knew it was configured properly. But when I turned on the pixel mapping software and I mapped some video to the LEDs, nothing happened. There's no output. And so I typed ipconfig and I found all of the ports, and then I ran a piece of software called Wireshark to see where the data was going. And I had connected the data internally instead of externally, and I could see that I had selected the wrong port in the configuration of the pixel mapping software. So that's a tool to help you figure out where your ports are, what they're called, what their names are, and then you can set it up properly in the software. Another application would be if you want to do what's called packet sniffing. So in other words, suppose I've got a console that's going out and controlling this lighting system. And if I want to use an Ethernet network, either ArtNet or streaming ACN, and I want to run these lights with that, I would go into the console, go into the settings, configure it to output either ArtNet or streaming ACN or some other proprietary protocol. And I'm going to cross my fingers and hope it works. But when I turn it on and start programming, if I don't have control of the fixtures, now I've got to troubleshoot and figure out where the problem is. Well, you can use a packet sniffer to sniff the data on the network to find out if the console is outputting data. And there's various ones, we'll talk about them later on, but you can connect your laptop to the network, but you need to make sure that you are looking at the right port, because when you connect to the network and you run the packet sniffing software, it's going to ask you which port you're looking for traffic to come into your computer on. And there'll be a list of 6 or 8 of them, and you need to know which one it is. Otherwise, it's going to be trial and error, and you might never find the right one, you know. So ifconfig and ipconfig is a way of figuring out which port is which on your computer. Does that make sense? Okay. Now, you might also be called upon to change the IP address on your device. And this happens many times. For example, has anybody here ever run the control app on their tablet called Luminaire? Are you familiar with Luminaire? And so it's basically a lighting control system that you can run on an iPad. And it's very popular in certain market segments, like in the film industry. And if you are going to set up your tablet, your iPad to run Luminaire and a lot of other things, then you have to manually configure the IP address on the tablet. Okay, so I want everybody to go in and change your IP address. All right, so if you don't know how to do that, I'll tell you how. On a Windows machine, the bottom right, you'll see an icon for Wi-Fi. Click on that icon, and that should open up a drop-down list. And look for something that says network, what does it say? Network, here. I'm going to get my Windows machine up. Sorry?
Change it that job. Change that.
No, there's another one that's more direct than that. And I'm going to look it up on mine because I tend to forget.
Internet settings?
Hold on a second, I'll tell you. Yeah, network and internet settings, you're right. And then click on the Wi-Fi icon and go down and find Network and Sharing Center. When you open up Network and Sharing Center, then you should see up near the top, there'll be another wireless icon that has a line going to the world, and there's probably an X through it because you're not connected to the internet. So click on the wireless icon, and that'll open a window. And at the bottom left, click on Properties. And then look for Internet Protocol version 4, and highlight that, and then click on Properties. And that should open a window that gives you the option to either accept an IP address using DHCP automatically. The option below it is to manually configure your own IP address. So I want you to manually configure your IP address. Now there's a pattern to it. If you want to stay on our network and communicate with all these other devices on the network, then you need to make sure the IP address starts with 192.168.0. something. And you need to pick a number between 1 and 254 and hope that nobody else has that same IP address, because if they do, the first person to claim it gets it, and you'll be locked out of the network, except you'll get no error message, no outward indication that you're not on the network. It just won't work. And then you'll pull all your hair out trying to figure out why. Now, if you're on a Mac, to change your IP address, go into network, or what's it called?
Go to the Apple, go to System Preferences.
System Preferences. And then Network, and choose Advanced. And then there's a tab that says TCP/IP. Click on that. And then there's a drop down for either get an IP address using DHCP or do it manually. So I want you to choose manually and change your IP address. Now, if you're on a tablet or a smartphone, you can also change your IP address if you go into the Wi-Fi settings. Okay? And remember, your IP address, your new IP address has to start with 192.168.0. And then pick a number between 1 and 254. Now, it will not take your new IP address until you close out all the windows. And when you do that, then you're going to have to log back onto the network again, because now you have a different IP address and the network does not know your IP address. So change your IP address, close all the windows, log back onto the network, and once you do that, then you can verify that your IP address is changed properly by typing, if you're on Windows, ipconfig and hit enter and look for your new IP address. Or if you're on Mac, type in ifconfig and hit enter and look for your new IP address. If you don't see your new IP address, you have not successfully changed it. Once you verify that your IP address has changed correctly, and if you want to test your settings in your network, then ping my computer, because I have not changed my IP address. I am 118.118. So 192.168.0.118. If you can ping my computer, then you'll know that you are still on the network and the network is still up and running.
You can always ping the router as well, right? Because that address is.
You can ping the router as well if you know the IP address of the router, correct? That's right. Okay? Now, if you're able to do that, now let's see if we can find the IP address of the lighting console. Does anybody see that? And how would you find it?
Got it. 219.
Oh, it's okay.
219, yeah.
So what changed? Did it just take time?
There's different IP addresses that you can set.
Different screens for different.
Okay. Yeah, it can be confusing, right? Okay, so now you should be able to all ping 192.168.0.219, correct? So that's the console. That's the console. Okay? Got it. All right, awesome. So there's a lot more stuff we can do with those, the terminal app tools. And, you know, that's a whole field of study on its own. There are people who dedicate their whole career to doing what we're just doing here in the last hour, you know. There's tons of stuff we can do. And that's really the tip of the iceberg. But that should give you an idea of what you can do with those tools. All right? So any questions about that? Yeah, Daniel?
What time would you be looking for to ping a console? Or does it matter?
Yeah, so Daniel's question is, what's a good time on the network? So when you ping something, it tells you the amount of time it took for the round trip, and so what should you be looking for? Well, I've seen it as low as 1 millisecond and as high as 250 milliseconds. So it just, you know, it's all, if you get longer than 250 milliseconds, think about this. One DMX packet takes about 20 to 30 milliseconds, right? So if you have a slow network and you're trying to refresh, like say you're trying to synchronize the strobes, you know, that requires precise timing. So if you have a network that has this slow and unresponsive, 250 milliseconds, that's almost a quarter of a second. You'll be able to detect that with your eye. So if you want a network that is as fast as a DMX packet, we're talking 20 to 30 milliseconds. It's not uncommon to have ping times of 64 milliseconds or something like that. What's the highest number you guys see? 824 milliseconds. That's almost a full second. Why? Because that's a $35 router. Right?
I got 1,428.
So that's over a second.
The biggest one I got was about 3,000.
3 seconds. 3 seconds. So that's important. You know, you want a responsive, and Wi-Fi is slower than a gigabit. You know, if you look at this switch right here, this is a gigabit switch. If we were hardwired to a gigabit switch, I guarantee you we wouldn't be seeing 3,000, a 3-second delay, 3,000 millisecond latency. You know, this has much more bandwidth than my $35 TP-Link router. You know, so, and you know what? There are fixtures like, for example, the new Arri's big in motion picture and film, and you know, and so they have their new Sky panel, and it has a slot on the back where you can put one of those TP-Link routers in there, slide it in there, and it holds it in place. So now you can use a tablet to change the scene. So would you want to use that in a discotheque or nightclub where you need, you know, instant timing? No. You use it to set up a shot, and they'll shoot for 30 minutes or an hour, and then you go to the next scene. You have time in between. You would not want to use the TP-Link Wi-Fi router for time-critical applications. You know, and so you have to take into consideration what the application is and figure out if that's a good solution for it. Okay? All right, so for the rest of the day, we're going to be talking about, you know, we just covered a lot of different, well, if you're not familiar with how Ethernet networks work, we probably introduced a lot of new concepts to you. We're going to go into more detail, more depth about what a lot of those things mean. And, you know, there's a lot to know about this stuff. So we're going to cover that for the rest of the day. All right? So let's go ahead and take a 10-minute break, and then we'll come back in 10 minutes.